Hi everyone, this video is on the mixed exercise of chapter 14, question 9. And this is an exponential modeling question. So the price of a computer system can be modeled by this formula, where P is the price of the system in pounds and T is the age of the computer in years after being purchased. So in part A, we want to calculate the new price of the system. When it says the new price of the system, it's talking about when T is equal to 0, because that's when we have a new system and we want to know what is its price, because afterwards the price is just going to decrease. So we just need to substitute t is equal to 0 into the formula, and we have 100 plus 850 times e to the power of 0, which is e to the power of 0 is obviously equal to 1. So we get 950 pounds. So that's the new price of the system. Now, in the second part, we want to calculate its price after 3 years. So I think this one is very obvious, because this means what's the value of p when t is equal to 3. So we just substitute 3 into t. So we have 100 plus 850 e to the power minus 3 over 2. Right, so we just need to simplify this, and this is equal to 289.66, and we can round this, so it becomes 290 pounds. Right, so that's the price after 3 years, and we can already see that there has been a massive reduction in the value. And the thing about exponential models is always that in the first few years, especially in the reduction question, the reduction itself is very huge, but as the time goes, then the rate of reduction decreases over time. And it can go the other way around as well. So in part C, we want to find when will it be worth less than 200 pounds. Okay, so in part C, we just have an inequality that we want to solve, because we want to know what's the value of t when basically the equation itself is less than is less than 200, because we want to know what's the value of t, or after how many years. Actually, we just want to know what's the value of t that p is less than 200. So this means that we just substitute the equation again. So 100 plus 850 e to the power minus t over 2 is less than 200. We have this. Now, we get 850 e to the power minus t over 2 less than 100. So we just solve this equation, and we can divide both sides by 850. So we have 100 over 850, which is 2 over 17, and we can pretend that this is an equation just to find the value of t here. So we can just say let this equation, and now we just need to take the natural log of both sides. So we have len e to the minus t over 2 is equal to len 2 over 17, but remember that len and e cancel each other out, so we have minus t over 2 is equal to len 2 over 17. And now we just solve this equation. So t is equal to minus 2 len 2 over 17, which is 4.28 years. So yeah, basically it takes 4 years and a few months for the value to be less than 200 pounds. And so in part D, we want to find its price as t tends to infinity. Right, so this is an interesting one, which is very common as well in the exam. So we just need to see that what's the limiting behavior of this equation. So what happens as t gets very huge? So if we increase t when it gets a very large number, then in the exponent, the power will have a very large negative number. And just remember that when we have the exponential to the power of very large negative number, then that's actually just going to be almost zero. Not exactly zero, but almost zero. So whenever you have e or any base, a positive base, and then you have the power is a very large negative number, then the output is a very small value that is almost zero. So that means that just to write this down, so as t approaches infinity, e to the minus t02 approaches zero. Therefore, basically p tends to 100 plus 850 times 0, which is just 100. So that means that the value of the computer will eventually be worth £100. And that just means that the value of the computer is not going to decrease more than that. So the kind of the minimum value will be £100, and the decrease is not going to continue forever, right? Because otherwise you'll have the value of the computer as zero at some point in the future. And in part, if we want to sketch the graph of p against t, so it's very simple. Okay, so we have t and p here. So remember that the y-intercept is when t is equal to 0, and we already found that in part A, that's 950 pounds. So that's here. And then remember that the asymptote is 100. So we found that in the previous part, because again, the value of the computer is not going to be less than 100 pounds. And then this is decreasing, so we'll have this graph. And finally, comment on the appropriateness of this model. I think this is a fairly good model because unlike some other maybe quadratic or linear models that we have seen before, in those the decrease or increases in a very unrealistic manner, because normally, especially in linear ones, everything is just constant, right? The price is constantly either increasing or decreasing forever. But that doesn't quite work like that in the real world. So I think it's a good model because this shows that it's kind of realistic that the value of the computer will never be less than 100 in this context. And that makes sense, right? Because the value shouldn't decrease constantly. So yeah, I think this is a good model and it's fairly realistic.